Hello again, welcome back. This is Johnny Rush, your host, and we are doing another live stream on 3D game development using Unity, and specifically working on our personal gaming project called Harvest. On the last stream we talked about, incorporating or starting to incorporate some kind of enemy NPCs, maybe some AI, that kind of stuff, so that we could at least interact, with our pistol that we got shooting, to interact with that and make sure the damage system works on the bullet when it hits an enemy opponent. And so that was the direction I was going to go in. But I kind of took an alternate route and decided to do something slightly different. It's still related to what we talked about. I showed this nice 3D model of a tiger that came with some animations that I downloaded from the Unity store, and that was the enemy that we were going to use, the first one, to kind of toy around with our enemy AI system, and of course shooting and making sure all that worked well. I kind of skipped the shooting part because I got sidetracked, or decided to focus on really learning the Unity Animator and Animator system. I had never used that feature of Unity before, and I wanted to understand how, from a script, a C# script, how I could access the animations and trigger those animations within an animation file that's included with a 3D model, for example. In this case, it's the tiger. So that's kind of what I worked on, and then from there, as I really kind of started to understand that, I moved into well, let me simplify basically what I did. First of all, I added in the tiger. I dropped it into the scene here. Created an enemy spawn. I dropped the tiger in, and I had to kind of rebuild or create my own tiger game object from what was included with the one that I downloaded. The one that I downloaded was set where it would automatically go in sequence through all their animation clips. So they had one set up where it would start at idle, then it went to a walk, then it went to a run, it went to the attack, and then it went to the roar, and actually the names in those were not exactly named that way, even though that's what they were doing. So I renamed all their animations and renamed the animation clips to match the animation name, and it kind of started with an empty game object and added the animator component and went through and finally got something that I was able to use with what they provided. So so right now I have them dropped in. I unchecked a couple of scripts I wrote. Along the way, I wound up, once I got them dropped in and working, we were just standing there idle, I decided to, like I said, start working with the animator component of Unity, which I had never used before, and trying to interact with that through scripting to control this tiger as if out in the third person view. So I basically tied him to additional controls. I didn't really want to mess with, because I had my player in the scene at the same time, I didn't want to mess with the AWSD keys, or I couldn't use the left shift for sprint. So what I wound up remapping, I used the UJHK set of keys. So the U was forward, H was left, K was right, and I may not even use J. I think it's just UHK over there. And then I use the right shift for a sprint to transition the tiger into a sprint from a walk. And I had the attack and the roar bound to the left and right bracket keys that are to the right of the letter P in the keyboard. Um, they're kind of acting quirky. I don't know if it's something with the animation or what, but it doesn't seem to want to respond as quickly as some of the other animations. So, or not respond at all. So I'm going to work on that. And maybe the way I have the animator set up, the animator window with the transitions going into those states. I originally was going to allow the roar or the attack to occur or transition from any state. That's the way I had it set up. If we look, matter of fact, let me bring that window up so you can see. Now, there's an animation window, but that's different than the animator. The animator is setting up the transitioning between existing animation clips. The animation window, from my understanding, allows you to actually create new animations. So I'm working with the animator, and I was trying to figure out how you can scroll this around. Apparently, you got to hold down the Alt key, and then you can drag your thing around. So if you ever get one of these from someone, and you can zoom in and out with the middle mouse button. If you download one from the asset store and you're trying to get to the animator window, and this thing is like all jacked up way over here and you can't see it, first of all, zoom out to find out where it's at, and then you hold down the Alt key and center it. And I know there's a quick way to do that. I accidentally hit it before, but anyway, I'm doing it this way. So here's what I have. You start with the Tiger Idle, and I set up several states, and that may be, originally these were not tied to the strike. I might go ahead and remove those transitions. All right, so basically the way this would work is, since I'm going to come back to these at a later point. So we've got this Tiger Idle state. This is a state machine here for the animator. And so you to create a new state, you can just right-click, create state, create empty, and then click on new state. You'll get to the right here in the inspector. You can change the name up here in a tag, which I put all. If you look at the Tiger Idle, I named it Tiger Idle, and I created the tag called Tiger Idle. And then your motion is just your clip. So you would search and find the actual clip which you want to tie to that particular state. And then we have these transitions, which are created by these lines that are connected between here. And the way you create one of those lines, you would right-click on your state, click Make Transition, and so it gives you this line. You just drag it down to one and click it, and see it created that transition. Now, normally you want to have that transition trigger based on a certain condition. For example, whatever this, let's say this new state was, let's name this test jump. And I'm going to delete this. I'm just showing you how you would set this up. And I'm not going to worry about the tag for now. But all right, so test jump to Tiger Roar. You click on it, and it gives you some information here. You've got this option here, it has exit time. You hover over, it says transition has a fixed exit time, which means you want to play that entire clip, or the transition time is fixed, you know, the blend between one transition and another. It's not like it can jump out in the middle of that transition and just switch to the other one instantly. Normally you leave that checked on to get the best transition through it. I unchecked it on a few, and I may have actually unchecked it on those. And so you're going to have to play with it to see what works better for you. But anyways, okay, the source state does not have a motion. So you would pick a motion. For example, well, you have your motion clip, but any of those clips. But what's important here is the conditions. This is how you would trigger it. You click on the plus sign to add a condition. And now I've created, if you look on the left here, it says layers. We're in the base layers where I'm creating this. You can create multiple layers of animation so that you don't have all this stuff all, jumbled up if you need to layer it. And that's on this simple animation here, I didn't necessarily need to do individual layers. But layers come in handy when you have a partial, let's say you have a fully animated character that's running, for example, and then while he's running you want to just affect the arm movement, for example. You could create that on another layer and then apply just that layer animation to the existing animation that's already going on. So it's used in additive and gets into a little bit more complex animation, which is above or beyond what I need here, or what I'm willing to take time to learn right now. Eventually I will, but right now it's not what I needed. So anyways, these parameters, when you click here, you set up a few parameters that you're going to access from outside of the Animator component from scripting. And so when you're looking at, for example, in this case, the tiger idle, the tiger walk, and the tiger run, obviously he's going to be moving at a different speed, ideally. Idle obviously being a speed of 0. Tiger walk could be a speed of whatever you want, and then tiger run. And so I created this variable called speed, and initially it's set to 0, which I'm going to represent as my idle state. My walk, I set that from code now. On the code side, a walk is a 0.25 and a run is a 0.75. And then I set up these other two Boolean variables, is attacking and is roaring, which were used to trigger the tiger strike and the tiger roar. Tiger strike being the attack, and of course the roar being his roaring. Again, I'm going to come back to those. Those aren't quite working like I want. I want to be able to use them with any transition, whether he's idle, when he's walking, running. So I guess what I would have to do is somehow, when he'd roar, when he's walking, he'd probably stop at some point and then roar and then continue walking. And then when he's running, he would stop and roar and continue running and following, a player, for example. But I'll have to work all of it out. Like I said, I'm learning this. So anyways, going back to using the speed, you can see on the idle transition. Let me expand this out here so we can see this better. Okay, we got a couple of conditions. The first condition I set up for this transition to go from idle to tiger walk. And the way you actually select the transition is once you have these lines linked, which are transitions to and from these different states, you click on the little triangle on there. That's what highlights it for you, and it shows you the actual animation here for that and the time and how it transitions. This little segment here, which is the crossover area, is the blend of the transitions. And so the conditions that you're setting here are when it would start blending between one transition to the other. For example, in this case, the idle to tiger walk. So now I set for it to go from idle to tiger walk. First of all, the speed value that's here, which is going to be a value that's passed in externally from a script, needs to be greater than 0.1. And so that's why we have a walk value, speed value of 0.25 in code. So it's greater than 0.1. And also, I set a second condition. We want to make sure it's less than 0.5, because there's some quirks if you don't kind of get both conditions in there that I noticed when it was going from a full run walk to idle, sometimes coming backwards down from run, it can go straight to idle. So you can't do it in one statement like you can in script or code, where you can do an double ampersand in C# to do a multiple condition in a single line. So you have to do each condition. And so as long as the speed is greater than 0.1 and less than 0.5, which in our case in the script we would pass it a value of 0.25, the animator, this animator control here will automatically start transitioning the object's animation from the idle state to the walk. And the same applies for the tiger walk to the run. If we click here, we only need, since run being the top state as far as speed goes in our animation, I only had to put one condition, which was that speed is greater than 0.5. And in script, we're actually passing 0.75, which is greater. Now you can use any values. I could have used 0, 1, and 2, and just, they don't really have an equals. It's greater or less are the two choices for the condition here. So you just have to put some value that's, greater than, or a value that when you say it's greater than, that your value you're passing into speed up here is in fact greater than that condition, so that can be met. And so that'll cause it to switch from walk to run. And now the reverse, when we look at run, going back to walk, now we should have two conditions here. First of all, we want to make sure when the speed gets that's passed in is less than 0.5, then we're going to, and speed is greater than 0.1, we want to make sure that it's not 0, because if so, it'll go right from a run to an idle, and it's kind of awkward when it does that. But so you just transition it out, and it may happen in maybe a quarter of a second where it does go from run to walk to idle. But you need to put these conditions in so you get the best control over this animation from the code, that when you're passing a certain speed, in fact, it's going to execute one transition to the other. So that's how the transitions work between states. And so you set up your animator that way. So I was going to show a new one, but let's just delete this. This doesn't really make sense to go from, because we don't really have a jump yet. There's no jump state, and that's something I want to add. We'll do my own animation for the jump and add that and fix the roar and the strike. So I'm going to delete that out. So this is what we have right here. And I'm going to leave this state machine the way it is. We're going to be setting is attacking, is roaring in code. So these items get, when they're, essentially this is the visual representation, but when it's checked it's true, when it's not checked it's false. But these values, these Boolean values are currently not being used in the animator. We'll come back to that. Okay, so looking at the script though now, let's go take a look at our script, how do we access this animator now that we've set up with this state machine. Alright, so let's go to enemy controller. That's the first one I set up. And so we set up some variables here that we're going to need. Obviously we're going to need to set a walk speed, we need a run speed, I had a turn speed, and we have our idle speed. Our idle speed, of course, should be 0. The turn speed is just a speed that we're going to use when we're navigating left and right. We don't want, if we have too fast of a speed, we don't want them to make a quick, sharp 90-degree turn. I almost think the turn speed is a little bit high, so we'll probably adjust that. But these are all public variables that are set up so they show up in the inspector. So these speed values here are not, these are the speed values that are used to move the 3D model of the tiger through the environment. These are not the values that are actually being passed into the animator as the speed parameter. What I'm using for that is the move variable, which determines the animator clip to play the transition from one clip to another. And so the move is just a variable that holds either a value of 0, 0.25, or 0.75 in our script here. Now speed here is the variable that's going to be set to one of these speeds right here, so that well, actually not turn speed, but because that's used in the rotation. But the walk, run, and idle speed are three different speeds that will be set or assigned to the variable speed within our code, so that we can use that to control how fast this 3D model is running through the environment. And of course, we're synchronizing the animations along with that by setting the proper move value, which is going to be passed into the animator controller to animate the correct clip at that time. So, all right, so just ignore that comment. I'm going to come back to that. Right now I have the tiger dropped into the scene, so I don't need to actually get an instance of the tiger, like spawn him in, because he's already there. But we're going to change that because I don't want him hard-coded into the scene like that, but it was easier initially to work through it that way. Alright, so the first thing we need to do is let's look at our tiger object so you can see what I have on it, so you can understand where this stuff is coming from. Alright, so let's just close all that. Here's our enemy spawn spot. If we switch to the scene view, you can see that's where the spawn location is at, right there. There we go. I just select so we can see the arrows where the spot is. Now we got a capsule collider around him, and I probably want to shrink that down just a hair, but radius to 0.3 maybe, yeah, something like that, or maybe even smaller. It looks like it could go smaller, but anyways, we'll leave that the way it is. 2.5, 3. We'll leave it at 3 there. Okay, so anyways, what we have is an animator component that's critical to this, and I'm using the default. They included a they called the Tiger Idle avatar, and it looked like they had an avatar for. See, the way they had their clip set up, or the sample stuff you download, is they had a separate animation object for each animation. So they had like this model, the mesh, and a different avatar for each one, but they're always the same. The avatars were always the same, and so was the tiger mesh. If you look down at our right here, they had this in here. It was the same one on every single one. Let me show you what I mean by they had all this standard. If you look at the tiger here, see they had all this separate. You had a tiger idle, tiger roar, tiger run, and that was not going to work for what we needed to do. I wanted to take control of this as if it was like a playable character, and so to experiment with the animation. So in order to do that, I had to extract out. If we expand these out, you'll see there was like a tiger idle clip. We have a rig, we have a mesh. These are the same. The rig and the mesh are the same in every one. They just had different names, like different, I guess you call them prefabs for the various states. But what I did was just combine it, make one, and add a script that will control switching between the clips. And that is this enemy controller script. So right now, by default, it's set up for the idle state. So if we were to just hit play, for example, right here, let me just show you. Without the script being checked, I have the enemy controller script unchecked as well as the AI enemy controller script, and so he'll just stand there in an idle state. And that's the idle animation. Just continually doing that over and over. All right, so let's stop that a minute. Now, currently, we can't do anything with him other than that. Look, if I press the U, H, J, K, nothing. He's not moving. Okay, now they did have a script with theirs. It was called Tiger here. Like I said, it was all tied together, and it just automated everything. I wound up writing my own animator controller, are doing the animator controller. That's actually the what you see here, the animator state machine, which is the controller. And I saved it, gave it a name of Tiger Animator Controller, and just dropped that in there. Now the other thing I had to do was create. I didn't have the AI enemy controller. We'll go to that in a bit. This enemy controller script. I'm going to enable that right now. And let's go back to our scripting here. This is the file that we're in here, this enemy controller. And so the first thing you need to do in order to animate this object that has this animator component on it, and which includes all those animation clips, so you have to get a reference to it. So we set up a private variable called anim_anim, which is of type animator. And I set bools for is attacking, is roaring, which right now that's not working. But and then in the start, we just get a reference to that component just by typing get component animator, which will extract the animator component of the parent game object for this object, this tiger. And then we set up some default values like the move, which is the value that's being passed into the animator component as speed internally. Is set to 0, 0. That's what triggers in the animator the idle to play the idle clip. And then we set our and actually I defined idle speed as 0. We have a variable for that, and speed at 0. Now, I wanted to make sure that the animation and the movement happened every frame. Initially I had it in the update, and sometimes it seemed like it delayed a few frames or like a quarter of a second, or just kind of acted strange. So I moved it to the fixed update function, which is generally for doing physics related stuff, but which is altering, transforms and different things, and anything that could alter physics. But you can also use it in animations when you want to make sure, because fixed update is guaranteed to be called every frame, whereas update is not. Even though update occurs every frame, it may or may not necessarily be called every frame depending on the load on the CPU. With fixed update, regardless of whether the CPU can process everything at once, it will get updated. You may have a laggy frame rate or a low frame rate, but you're guaranteed to run it every frame, and that's critical with the animation side. What I noticed, I got better results here. Alright, so the first thing we're going to do always, at least the way I set this up, is I'm going to assume an idle state at the start of fixed update. We're going to assume he's in an idle state, and then or we'll put him in an idle state. Now, based on, you see all these input.get keys I have, based on what key is being pressed, U, which is a walk, then I'll alter or modify these values. So basically, if you let go of a key, because this is looping, every frame, it'll automatically switch and set the values to the idle state. So it'll essentially stop walking or stop running. Now, so we've got U mapped to walk, and all we do is say the speed, which is the animation speed in code in the environment, is set to walk speed. Remember, these walk speed is set in the inspector. If we jump there real quick, I don't know if I showed you that. We go to Tiger, and you look down here on the script, enemy control, you've got walk speed, run speed, and turn speed. And let me drop that turn speed down to 2.0, just 2. So there we got 3 for the walk speed. The run speed is 4 times that at 12, because the Tiger runs fast. And then we have a turn speed of 2. Alright, and so that's where those are coming from. The hard-coded values you see are what we're going to use to set move to, because that move is being passed into the animator component, and then it's used internally to trigger transitions between the animation clips or states. Um, and so on a walk, we set move to 0.25. And then the run is right shift. Now I check to make sure we're walking first, because I don't want to trigger a run from um, just an idle state. Um, so unless you're already walking, it's not going to trigger it. If you're sitting there idle and you hit the shift key, he won't start running. He shouldn't start running. Although we could make it that way. We could make him just run right away, but it would be like a quick leap. I want him to start walking first, so you have to hold the U key and then hit shift, because while you're holding U, you would have triggered the walk speed, and then it would transition from a walk animation to a run. So originally I didn't have that in there, but I added it to make sure that we are in fact matching your state machine the way we've set up, and we're controlling that through code a little bit better to match that state machine, even though the animator will control it and only trigger it when it needs to be triggered. We have to write some intelligent code somewhat that will mimic that as well. So so that's what we do. We just set the, if we are on a walk speed already, we'll set the speed to the run speed value, which is, again, this is coming from the inspector. It's actually 12. And we set the move to, which is 0.75, which that's what's passed in as the speed value inside the animator. And so a turn left, essentially we're just rotating our tiger. So we use a simple transform.rotate. And this is where we use the turn speed. When we're turning left, it's a negative turn speed. When we're turning right, it's a positive turn speed. And we just pass it in a new vector 3. X and Y, you can see that we're not modifying the X value at all, so we just set that to 0. It doesn't necessarily say we're zeroing that out. We're just not applying an additive or subtraction from the current X value. Just set it to 0, which means nothing. And then the turn speed is, of course, the Y value. Now this is on a rotate. The Y value corresponds to an axis, not an actual position Y value. So it's the vertical or up and down axis, the Y. So you're going to rotate them on that axis, left and right. So that's H and K. Like I said, the left bracket set up for the attack and the right bracket for the roar. And I set it up that if the speed was equal to idle speed, then essentially what it does is it'll toggle between, when you tap it, it'll toggle between an attacking mode and not attacking. So it sets those variables. And so right now, up to this point, and same with roaring, so up to this point, we are just setting up variables. Nothing's actually happening in the animator. Nothing's actually happening to the 3D model itself. Those are just getting all the values set up to get ready for, with the exception of the rotate. This is directly rotating our because we're using the transform.rotate function, we are rotating the model at that point. But these others, like as far as movement in the left and right bracket, pressing for attacking and roaring, all that's set down here. Now, first of all, using our speed that we've set up, this value again is the actual movement that we're going to see on screen of the object, not the animation being triggered. You know, we calculate our basically the new position we want to move to, and we're going to use the transform.forward, which is the forward-facing direction of the model, and we're going to multiply that by a speed value, which is what we've set, and we don't want that to be like instant jumps of speed and 12, like right away every frame. We want it to be a nice smooth transition, so you always use you add this, basically not use, but you multiply your result by time.delta time, which gives you again, we talked about that on the last stream, gives you the millisecond, fraction of a second for this particular frame. And so you're only going to move that little bit in that little bit of frame, and over the course of a second you'll move whatever total speed distance you want per second, but it's going to be based on your frame rate. So you'll get the same result regardless whether you have 10 or 15 frames or 60 frames. Your tiger will move the same distance over time just by doing that. Of course, we got to make that change to the local position, which is relative to, because the tiger is relative to a parent object, we need to do the change to his local position. And these three lines here are how we tell the animator controller. Remember, we defined it as anim up top. We've got a reference to the animator controller as _anim. There's a function built in called set float, set bool, and set bool, set bool, and set. There's a set int, and there's a few other ones. This is how you directly assign a value from code to the internal parameter that's inside the animator that you've set up. So the animator parameter called speed, we're going to assign it the value, whatever we set move to in our script here. And instantly, when you do that, the animator will respond. The animator component takes care of taking that value, and it's constantly checking the conditions set up for all the clips, and it will automatically react to that setting change, or should react to it. Like I said, the is attacking and is roaring, for some reason we're not working right. So I don't know exactly why, but I'll have to work on that. I think on those I'll just have to play the anim, because you can play a clip directly. I might have to say anim.playClip. I think that's what it is. There's underscore anim dot play. That's what it is. Play, and then I could give it the clip name. That's inside. That's been defined inside there. I'm going to copy that just for reference, and we'll come back to that. Rather than try to set these bools, because I noticed that they don't seem to work. Like, the movement works fine, but these don't for some reason. So anyways, that's what it does. On the fixed update, every frame, we're updating movement values or speed values, and the move variable, which will be passed in to our animator as and assigned to the speed parameter that's inside there, and then from there the animator takes over. It's automatic. You don't have to worry about it. It's set up, probably running on its own thread more than likely, and does the animation just the way you ask it to. So that was it. That's as simple. I shouldn't say. It took me a while to kind of work through that, wrap it around my head, and so now that I have that working, I now know how to access and control animation clips, and tie it to code, so you can, basically synchronize it to events going on in code, like pressing arrow keys to control movement, or this could even be triggered. Clips can be triggered based on an event that's occurring in your game. I don't know. I guess I can. You could have animation clips set up for a gun, for example, which I'd like to do, like an explosion of dust. Well, normally you'll probably use the particle system for that, but if you had various animations for destruction, for example, of you shoot something and it explodes, and you've got these different animations that represent different levels of destruction of a particular item, you could control those animations over time, and more likely you would use the anim.play to specifically tell it when to play a certain clip out of the animations for that object. And so we'll look into that later. So anyways, let's get back to, now that we have our enemy controller script selected with a run speed of 12, walk speed of 3, and 2, let's hit play and show you how we are controlling a tiger now. With synchronized animations. Oops, I hit my character. Let me move my character back here where he can kind of watch from the distance. In the put him in the shade. I don't want him to get a sunburn. Okay, so I'm pressing U now. You see our tiger starting to move. He's doing the walk animation. Now we're going to turn right. So turn this way. Start walking toward us. I'm going to sprint by hitting right shift. I'm turning to while I'm sprinting. Just going in a circle, getting dizzy. He's coming to eat me. Oh no! He missed me. Let go of the shift. He goes back right to the walk transition. Let off the U. He instantly goes to the idle. So it also seems, I noticed, like the very first animation that you click on does something little, like hesitates just for a split second, but like now that I let go and it's almost instantaneous. So there must be some kind of initialization occurring the very first time you access the animator. So there he is rotating, turning left, turning right. Alright, so that's what I had initially. I just had him running around. And then for some reason, I got this crazy idea. I started thinking, okay, not a crazy idea. I mean, it's something that would need to be done anyways. I'd like to have these. I said I'd like to, now that I got it moving, it'd be nice to have him like an AI just moving around in a certain area and just moving on its own. And I was trying to think about, okay, what's the best way to do this? And I couldn't really think of. I knew it'd be really complicated code, and it would probably be not really the best way to do it anyways if I just try to write some code that just let them randomly move in random directions and all that. But instead, I knew that a lot of games use what's called a waypoint system for NPCs. And so I decided to come up with a simple waypoint system for that. But before we get into that, let me just, there's one more thing I want to show you here. I forgot. I've set up some cameras on our Tiger. So I got a TP camera, which is third person, or an AI camera. I'm going to enable the TP camera, and I am going to disable on spawn A. Just disable that script so our player does not spawn in, because you can only have basically one main camera in your game. You can have multiple cameras, but only one camera can be designated as the main camera, which is for viewing like this. So see the TP camera, I tagged it with the main camera tag, so we have to turn off our player. What I want to show you now is we've got a camera view that's behind this, and so I set this up so that this is how I really was testing, really got to see the movement in action and make sure that it looked all right. See, and you see their animation for the walk has a little bit of a hiccup. You can see it. It's like just at the end you can feel that little twitch, but that's the animation clip I got to deal with. And if I move left, of course, move left, right, left. So now we can sprint. There's the speed. That's the feel. That's how I knew it felt right. It feels good at this speed, moving at this speed. And with him running, it felt, decent. Now, initially, I didn't have a rigid body on him, and when I did, so when he ran off the cliff, see, now he's looking down, which is perfect. And we got a few anomalies here. I forgot I need to lock the rotation of the axis. Anyways, so there we are. Eventually, when he hits the ground, he'll even out. We need to fix that. But initially, I didn't have a rigid body on there, and so what had happened was whoa. He's like losing rotation here. He's not on ground, so that's why he's not. The animation is not stopping. All right, so we got a little glitch there. If you run off cliffs, that's kind of what happens. Let me take a quick look at him, see if we can remedy this real quick. Probably has something to do with the rigid body. Using gravity. Okay, we need to freeze, not position, but rotation. We only want him to rotate in the Y when we're turning. Really don't want him to rotate on the X or Z. So we can lock those. We can freeze those rotation axes, so no rotation will happen on those. So, and let's also bump his mass up to 150. That'll help keep him stabilized a little bit more. All right, so let's try that again. All right, so I'm gonna go off that same cliff in that direction. Now going straight down, he probably would be, no. He kind of did a little mid-air float. So there's something I would probably need to add. I've seen this in other controllers. They check for the ground distance, and so need to check that, you know, if he's airborne, he's not supposed to be airborne. We can readjust for that and move his position so he stays close to the ground. So that's something I'll need to work on. But if he's not jumping off cliffs, I mean, he's actually moving along pretty good, to be honest with you. Let's run across this bridge. We'll make our final. Yeah, and he's kind of doing, I can see this he's kind of doing when you hit curves, kind of like the, what do you call it, the Unity Standard Assets has a third-person controller. He's kind of reacting the same way when he gets on unlevel ground as theirs did. So that's all I did was a basic controller like this. I didn't put much effort into it. Obviously did a little bit more than what I did. But it has the same problems, and they leave it to you to fix them. So I wouldn't necessarily recommend using it, to be honest with you. If you have to, I mean, it's great to get started, but you can, spending a day, you can figure out, you know, some of this stuff and probably develop your own, at least that you've written and you understand, because the code is based off of, you know, what you've done. So anyways, we have a tiger movement going on, basic movement. So we've locked our now. So I noticed the tiger. Yeah, it took a while before he decided to stop walking. He didn't realize he was on the bridge there, or on ground. I noticed the tiger had issues going over, obviously off cliffs and stuff like that. So the next thing I wanted to do was have these, you know, maybe not necessarily the tiger, but, you know, the tiger would be one of them, but some other enemies, NPCs, maybe would be roaming around these trails or just moving around the hills, the, you know, lower part. And I'll probably smooth out some of the terrain and get rid of some of these ups and downs that are really crazy. And even look at writing a function again that can check slopes, and if it, you know, the slope is at more than a certain angle, he just won't be able to go up that. And so we'll work on some of those changes later. But I wanted to get a basic control in place, so I had him moving around. Now, next thing I did, like I said, was working on more of the AI side of it. And so what I created was, first of all, let's turn off our camera now. Third person. Let's add, there's another camera for AI. I'm going to add that. That's going to show, see, that camera is showing where he's at on the map. Initially I tried to follow him, like without this AI camera. I tried to follow him, and we can do that. Let's turn our player back on. Okay, so we're spawning our player back in now, and then got an AI camera. Let's go back to our tiger. And so now we have this other script I wrote. So that's the enemy controller. That's just to control the enemy if you want to become the enemy. And essentially I probably could, well, this isn't a fully rigged humanoid animator controller type setup, so rig. So I couldn't use the locomotion that came with the vector that I'm using for my first person my guy here. I had to. That's why I had to create my own controller, which it's nice to do that, and I kind of appreciate the hard work that these people put in, these companies, to put together a third-person controller. It's so critical and key to any game, whether it be first person. First person, not so much, because you're not seeing the full body, although you will see it from another person's perspective if you're doing a multiplayer game. So they really have the first person plus the third person going on. But anyways, not to get off topic here. I knew that I was going to need some kind of a waypoint system at some point, and so that's what I wound up working on, was a waypoint system. Some kind of AI. I was getting him to move around. So initially I only had a couple of waypoints, and I want to zoom out here so I can show you exactly where the waypoints have been set up. And so you see here I got this under our terrain. We've got these different empty game objects to organize some stuff, and we had our player spawns here, but I had this NPC waypoints. And so waypoint 1, you see that little green dot right there. Let me see if I can zoom in. And so actually, if I highlight that, you'll probably see it better. That's waypoint 1, waypoint 2, waypoint 3, 4, 5, 6, 7, 8, 9. Let's zoom back out now that we have that on. 10, 11, 12, 13, 14. Well, these are going up back to the same way. They're close to the other ones, but not exactly. I don't have any waypoints that are overlapping. 15, 16. Okay. So the way it works is first of all, I set up a script. As you can see, if I click on any of these waypoints, there's this NPC waypoint controller script. And it's got two public variables or game objects that show up. Actually, they're transforms. I take it back. Transformed set up on each. And so at waypoint 1, I tell it, okay, what is my, because this is going to be like, think of a track that goes in a circular fashion. And I have a previous and next waypoint. You just drag and drop the waypoint that will be its neighbor, more or less. It's considered its previous waypoint or the next waypoint. And so on waypoint 1, of course, the previous is going to be the 16, the last one, and waypoint 2 will be the next one. And every other one though goes. And it's like 2 has 1 and 3, 3 has 2 and 4, 4 has 3 and 5, and so forth, all the way up till we get to 15, 14, and 16. And then 16, of course, its previous is 15, but its next would be waypoint 1, back to 1. So it should create like a circular thing. And so I just wanted to, again, I was just experimenting with this. It's possible that, since when it's organized like this, I could create multiple waypoint paths by creating different game objects and have different ones here, have different ones for different types of enemies. But right now I just have one called NPC waypoints. It's categorized in this group, and so I didn't really develop any kind of scripting or code where I could pass it a group of waypoints that it should follow or go through. So now let's look at the scripting and how this works. We'll need to let's go to the waypoint first. We'll look at that waypoint NPC Waypoint Controller. This is the script right here. And so it's pretty much a simple script. I set up a few functions here that are public, which is going to, since the script is attached to each waypoint will have this functionality. We'll have a get next waypoint, which basically is just returning the reference to the next waypoint transform that we drag and dropped into the inspector. Get previous waypoint, and then get this waypoint. If it just wants to return, for whatever reason, if we need to know what this waypoint is, the transform of it. Now, in the as far as the other scripting goes, we just have an on trigger enter. Now, all waypoints had the first of all, each waypoint has a sphere collider that was added. So essentially, it's just a transform, which is your basic empty game object has a transform. So it's a location. We've got the script that was added and a sphere collider. That's essentially all the waypoint is. Very simple. I played around with the radius a little bit. I had it up to a 3 at one point, but I left it back at I set it to a 1, which seemed to be the best. And if we zoom in on the waypoint itself, let's go to an X view. It's a circular sphere, and I tried to get it where it was like just, you can see it start going through the ground there. It's close to the ground right there, and a size of 1, and so that seemed to be a good size. I didn't want it too big. I want it to be small enough, and maybe a smaller number would work. Where I didn't want it, but too small might, too small might be too small where it'll just pass through so quick. If you're running fast, that it wouldn't catch it. But I didn't want it too big where it could kind of get stuck in it, and that's what happened. I had this funny thing happen where the tiger got stuck because the waypoint happened to be like above the ground a little bit more, and it was big. It was a 3-meter radius, and he kind of got stuck and was going back and forth in the air, just being thrown around, and it was just really crazy because he didn't know what direction to go, and the logic kept throwing him, triggering him back to as if he was at a standstill there. It looked funny. So after a few tweaks, I found for me in this environment, and it may change, but a 1 radius was perfect for this, and a sphere collider. Okay, so let's jump back to our code. All right, and so the way this works is, first of all, on trigger enter, any moving object going through here could trigger this if it has a collider on it or a collider component. So, I wanted to make sure that right now I was controlling what objects go passing through this are actually affected by the waypoint system or utilize it. And for now, it's just any object that has a tag, a game object tag of enemy, which I assigned that to our tiger. I called him an enemy. And so the way the code works is this here is getting a reference to the AI enemy controller script, which is attached to our tiger. So real quick, let's make sure that we did in fact switch that over. Let's see, what do I have? Our tiger. Okay, we need to just turn to, I want to make sure I check it now so I don't have the issue later, and uncheck the enemy controller, because we're no longer going to be controlling it through keyboard input and all that. It's going to be an AI based, and so the scripting was different for that. But I used the same values for walk, run, and turn, same kind of parameters. And I also added, if you see here, there's a start destination, which would be the starting waypoint for this particular AI bot, or whatever you want to call it. All right, so let's jump back to our script. So that's what this AI enemy controller is. It's getting from the other object passing collider object it'll have its parent game object attached to it, and then from there we can get the component, which is the AI enemy controller script that's attached to the object that's passing in, which is our tiger going through here. And so the first thing I get is, and again, I created these public functions inside the AI enemy controller. These three functions get the destination, start destination, previous destination, and we store those in three variables: destination, start, and prev for previous. And then we do a check. We're going to check because if destination.position is equal to the start position and destination.position equal to the previous position, if those are all the same, inside the AI enemy controller script, the first thing it does is assign all of those to the same position, waypoint position. And so if they're all the same, that means we're just starting here. So we're going to just send we're going to send this AI bot, this AI enemy, to the next waypoint, and we're going to update its previous waypoint values with the current one. So so actually in this case we're not really updating because the previous is already set to the start, which we can leave that alone. That's actually, originally I was doing something like that, but I changed it and I forgot to modify the comment. So really all we need to do is just set its new destination, and we're going to leave the previous position just the way it is because it's equal to the start position, which would be the first one. So we're just going to set the next waypoint. So the way we do that, there's a function called set destination, which is in the AI enemy controller, and you pass it in a transform, which the transform would contain the XYZ positional coordinates on the map here. You pass it in here, and it automatically assigns those variables to the destination where it's going to go to. And then I had this swap speed function in there, and just to play around with variation. Basically what the swap speed is doing is it's tying in with the animation, and it's just swapping between a walk and a run state for the tiger. So it can, instead of him running either walking all the way or just running all the way, it will change up that speed. So initially he starts as a walk. We swap the speed after he reaches the first destination, so that he goes into a run from the walk, and then we swap every other destination. We're swapping the speed again from a run to a walk, and so forth, and walk to a run. It's going back and forth just to mix it up. That's the only reason I did that. I could have just set the speed to a walk, and when you hit the first one, do it to a run. And the other thing I don't have any way to know what his final destination should be. So essentially he'll just keep running. In this setup here with the script, he's going to keep running from waypoint to waypoint, never stopping. But I would like to add something called final destination and or end destination, and be able to define that. Like we have a start transform, we pop in, we have a an end, and so they would go through the AI enemy would go through the various waypoints, starting with the one he starts at, and get to the end and stop there. It may be, because again, this could be used for, I'm thinking down the road, maybe our player interacts with someone and we want to send them on a quest to go see somebody somewhere. How would we do that? Well, this waypoint system could, in fact, possibly work for that. You just set him at the starting point, maybe where you're at, and send him to his destination, and he'll keep hitting all the waypoints until he reaches his destination. How well that will work, I don't know yet. That's not implemented all the way, but this kind of system could work for this. And using this tiger, we're experimenting with this to make sure he goes through each waypoint and continues on. So initially, what we're going to do, so we can see this is working. Well, I guess we can still see it. Okay, so that's the basic script for the waypoint controller. That's basically all it's doing is when an object collides with its trigger zone, which is a sphere collider, it check set objects tag. Is it an enemy? Okay. Then it will go ahead and send it off on its way to its next. Basically, it's updating the waypoint, the transform variables inside this AI enemy script that's attached to that enemy that's running around. We're updating its previous and its next destination and all that, so through these functions. So now looking at the AI enemy controller. Obviously this is going to be a little more complicated because it's a blend between the controller we had for controlling the run, walk speed, turn speed, and we have our public transform start destination. So we're going to end a final destination in there later in a future update. So anyways, what we're tracking here, we got two transforms internally. These are the internal variables, which I mark here. We got the destination, which is where he's going to go to, which is essentially what we call get next destination, or that gets assigned to the destination where he needs to go to, and then the destination he just arrived at is stored in previous destination when the destination is updated. So, and we got similar variables: idle speed, our speed and move, just like we had in the controller. So by doing the controller, that really did help. This was the first step in doing that. A lot of this is all the same. One thing I did do was define the variables for the speed, for the move variable that's going to be passed to the speed parameter in the animator component. I defined them as constants. So we got idle speed and all in caps. Constants are generally defined in caps and across the industry as far as programming goes, and that's how just by looking at it, it's a constant versus a variable. And the difference between a variable and a constant is a constant cannot change. Once we set these values, there's nothing in code that can change the value of idle speed or walk speed or run speed, the capitalized versions here. It's set one time, and that's it, initialized at this point right here when you define it as a const. Everything else is the same. You look at the way it's defined, private, float, variable name equals value. The only difference is you have this keyword modifier called const, which goes before the variable type but after the declaration of whether it's a private or a public variable. And then I use those constants in the code here just to make it easy. You can see here the move starts at walk speed, idle speed is idle speed. Of course, this is our speed variable, which actually should be set to, well, it's set to the value of walk speed, which walk speed is set up where? Actually, walk speed is in fact not set up. Maybe that's part of my little glitch here. So let's say walk speed we might not even need it. I don't know, but oh, I take that back. Never mind. And that's what the confusion part. Okay, walk speed is the parameter that's set. That's a public one up here that's set in the inspector. So yeah, we don't. That's what it is. It's pulling it from there. Okay. Let me just make a note there so I don't get this confusion again. Pulled from inspectors setting. Just put it that way so we know. Unity inspectors. Okay, so that's what we do on the start. We're basically just, here's where we're assigning, like I said, we're assigning the current destination to the start destination, which is pulled in from the inspector. And then we just assign the previous destination to the current destination. So they're all assigned to the same thing at the start of the script when it's running on this let me just save that, on this AI enemy controller, this enemy. And so we get the same reference to the animator component, Everything else is the same here, so that with the exception of using constants instead of hard-coded values. Now, one thing I did was to clean up the update function is I created just a function called move, which is called, and inside move here, this is where we have the code that actually moves our is going to move our actual AI. So the move code is actually very simple. First we get our step, our movement speed, the amount that we're going to move for this frame. And all it is the speed times time delta time. So we broke it down that way as a step. And 2 lines of code. We're using something a little different since these are functions that are built into the transform component, which is part of Unity. Unity has a function called lookAt, which essentially what that's going to do is when this enemy, this tiger, hits the waypoint and gets its new destination, we tell it to move. It's going to continually look at the direction of another transform, which we pass it the destination.transform. So the transform of our destination, our new destination, where it's going. So that function there will keep the rotation of that object looking at your destination. And now as far as updating the position, which controls his movement, the vector3 class has a static function because we don't have to use the new keyword. That's how we know it's static. We don't have to actually create like a vector3 variable and then use it. It's a static function built in, so we can just access it directly. So there's a function called move towards, and if we hover over that move towards, you pass it your current position. And I know it's a position because it's a vector3, which a vector3 is an XYZ value. So you pass it your current position, which in our case is going to be the position of our tiger, wherever he is in the world. So in his transform, that position will give us that. The lowercase version word transform is the transform component that it's a reference to the transform component that's attached to your game object. So that's what we're going to pass in, transform that position. The second parameter is a target. Okay, where do you want him to move towards? What's the target? And so we pass in the position value of the destination. So you do that by referencing underscore destination dot transform dot position. That gives you the position of that transform, which is the waypoint that it's going to, the XYZ position of the waypoint. And the last value is the maximum distance delta, which means what is the maximum distance that you want him to travel for this frame. What's the maximum distance he should move, and so that's our step value. So we only want him to move a small incremental portion for every update, similar to the way we were doing it with the movement before, but with a key stick, or a keyboard binding. So actually, looking at the code, it's very simple. Get him to look at a location. Now, granted, this is more of a direct line of sight, hence the need for multiple waypoints, which kind of helped the tiger traverse down the normal pathway. The more waypoints you have, the more fine-tuned you can get with this. Now I put up 16, which took enough time just to get that set in place. But anyways, so that's our move. And then here's our functions, of course, we had for the set destination, which is called from the NPC Waypoint controller script, where we actually pass it in and assign and store, the new destination, the previous, and when we can other functions to get the previous destination, get our current destination, and get the start destination. And there's also a function called start running, which start running takes a bool, a true or false. Do we want to run or not? If we want to run, we set the run speed we set the move and speed values to the appropriate variables. This being a constant run speed, and this one being our inspector variable for run speed. That assigns those. Else, if it's with this is false, that means we're not running, we want to walk. Because those are really the only two states we're using during the transitioning from waypoint to waypoint. It's either a walk or a run. And then we set the move speed to a walk speed and the speed to a walk speed. Now, swap speed, we talked about that. Let's put that back. I want to leave that code the way I originally had it. I commented it out just so I can, for debugging purposes, I can have running full speed all the way from waypoint to waypoint. And so the way swap speed works is if the current move is equal to a walk speed, then it'll start running. Else, if it's not, then it'll pass in false to go. Basically, it'll say start running true. It'll swap it to a run, false otherwise. Because if move is not equal to walk speed, then it's already equal to run speed, and then we want to basically transition them to a walk speed. Now remember, swap speed is called an NPC waypoint at key times, only when he initially, during the first waypoint he starts, he enters, and then after he reaches, when his destination reaches the transformed out position. If that's, if they match, that was, that he made it to his waypoint. So we swap the speed there. I also had this check, and maybe later on something could be done here, we might need it, that if the destination dot position is not equal to transform dot position, meaning he crossed through a waypoint that he wasn't supposed to be going through, we don't do anything. We just kind of let him pass through and keep running. We don't want to reset his destination or re-navigate him, otherwise he won't continue on through the path that's been laid out. So I really see that this could be with the final destination component added here that we talked about, the variable to track that. We could have different waypoint paths that go from point A to point B, and we'll keep an NPC on a reasonable path so they're not going off cliffs or doing crazy stuff like that. That's another reason why I created so many waypoints. Like I said, to keep the tiger from going off a cliff and doing some crazy roll, or just doing some stuff where he's hovering in the air, because the physics don't seem to. There's not a maybe a way where I can change that where the physics work like instantly on the mass as opposed to a gradual, and it may have to do with the drag value. I need to look at what the drag. If we look here at a rigid body, we get a drag and an angular drag. I need to see what those values mean. So I might be able to correct that, or not increase the mass so much. 'Cause I'm trying to increase the mass to get them to fall quicker. But at some point, the physics has a realistic simulation of a fall. You only fall at a certain rate, at a certain speed. Once there's the maximum speed that you can fall at. And so that's why he's still in the air. I need to have him instantly go down, and maybe with this drag possibly I can work with that, or I may have to do a ground check distance and then see how far the ground is. That's probably what I'll do. We're using a ray cast. That's what I've seen. They're doing a ray cast from the base of the tiger's feet to the ground. It'll get a distance, and if that distance is greater than like whatever the minimum ground distance is, for example, it's usually 0.02, 0.03, something really small, which you can't even tell by the naked eye whether he's at the ground route, then it will actually move him to that, whatever the raycast offset is, it'll add that in and keep him flush against the ground. I'm going to work with that and improve our AI enemy controller model later on. So anyways, without further ado, I think we covered all the code. And again, he's starting at waypoint 1. Let's watch him in action. We're going to actually follow him. Now that we turned on the swapping between the speeds, we can actually keep up, because at a speed 12, he's much faster. At a walk speed, he's, you can see he's actually slower. He already hit the waypoint. I forgot I had moved him closer. So he's running now. So we're going to have to try to keep up with our buddy. Let's hope the speed swap thing is working. He's walking. Yeah, he is. He did walk. See it? He hit the waypoint, and now he's walking. Gives us a chance to catch up. That's the reason kind of did it. In addition to making it mix it up, gives us a chance to mix up. Now we can, our controller can go downhill, it's fine. Now we're out of sprint stamina though. We're going to need to take shortcuts just to keep up with him. And so our next waypoint, I believe, was like down here somewhere. Right where those roads kind of, the dirt roads kind of cross. I'm out of sprint stamina. See where that tiger's at. Where'd he go? See that far behind, or did he get way ahead of us? Oh yeah, he's way ahead of me. He went down the hill. That's sneaky. Sneaky, sneaky thing. Alright, so there's a waypoint that's going to be up at the bridge. That's apparently when he's going to slow down. So he really had a good sprint distance across here. And so this is how I initially was testing him. I should have turned off my thing where I had full stamina. I should have set that where I have full stamina. He should be walking across the bridge though at a slower pace, so we should be able to catch up to him. He'll probably be long gone. So what we'll do is we'll take a shortcut here. We'll go this way. We're going to wait for him because the way the waypoints are set up, he's running across the bridge and around the volcano, going further out to the I guess the west coast there. There's a waypoint there, and then he starts coming back through this across this way. So what I'll do is just sprint up here real quick. I want to get where I can see him coming. If I see him coming, I know he's making it through all the waypoints. Occasionally, there was a few hang-ups. I had to tweak some things. I just tweaked them this morning. Like I said, reduced them down to a size of 1. Try to get him the highest point possible here so we can get a better view. Hopefully we didn't miss him again. Yeah, we'll just wait a minute here and wait for him to come. He is going a pretty good distance. There he is. I think I see him hopping over there behind the hill there, hill edge. He's walking though, I think. Let's see. Yeah, there he is. You can barely see him. He's coming up and over the hills. He's actually in a sprint right now. There he comes. Full charge, full speed sprint. There we go. So far the waypoints are working. Yeah, see we got some issues there. See he's not quite hugging the ground. So we're going to work through that. Now that we have full sprint, let's see if we can catch up to him. Hopefully hit a waypoint down there that is setting him into a walk. Yeah, so he hit that waypoint. I saw him turn, but he's still in a sprint mode. So I've got something going on there. It's not swapping properly to walk. And I think what's happening is he's, for some reason, the waypoint's like triggering that twice in succession, which is throwing it off. And anyways, you get the point there. So waypoint system is coming a long way. Now the other thing I want to show you, I did, like I said, it was getting difficult to keep up with them. So, like I said, I added this AI camera for a reason. This is the cool thing I was using. Save the scene. Now, I don't know if we went over using render textures before, but a camera has the ability to render its view to a texture and there's a special kind of texture called a render texture, which is basically a raw image, and it gets raw image data from the camera, and it gets it like every frame. It's updated every frame with the current view. So what I took was a render texture, and I simulated a. Let's do this. Where's our player? I'm gonna zoom out a little bit. I'm gonna move this player back to where he was so you can see. I just want to bring him inside here, that's all. Alright, so let's hit play now. You see I set up this render texture on the wall here. I took a plane, basically a plane, and adjusted like a big screen TV. And so I can stand here without having to chase him. I can get a view of him. Now I see that he triggered. He went from a sprint there. It did swap to a... Let's back up a little bit. It did swap up to a slow walk. I can tell by the way he's moving. He's in a slow walk. So I was able to just kind of sit back here and not really fool with it and just watch a movie and watch him go through the waypoints more or less. I have a little kitten here in front of me. She's sitting on my desk looking at the screen, the monitor, and she's actually watching the, there you go, sprinting, watching my character, and she's trying to scratch at my actual player here, seeing him kind of move. She thought that she could, but I got to keep her away so she don't scratch my screen. Okay, so he's running through the waypoints. He does a sprint, and I guess I want to see if the swap speed is in fact working, because it should at every waypoint should be triggered once, but I need a way to make sure it's only being triggered once. I think that's part of the issue. See, he's still... He's at a that's a run speed there, I believe. Yeah. He's still at a run speed. So it's not swapping back. It gets to a, it's like the first few times it worked, and then it stopped working. And so I don't know what that is. Again, maybe my sphere collider is still too big. And so as he's running through it, it gets triggered multiple times. That's the only thing I can think of. I guess one way I could debug that. I've been doing this debug.log thing all through my code. I need to go into the AI waypoint code, and each time swap just above the line where we call swap. Okay, there he turns around. It was a sharp. I don't have a quick or what do you call it? A smooth transition. When he hits a waypoint, it automatically, you know, rotates him to that direction. That's why you're seeing that flicker when he hits the waypoints. It's not a smooth transition. That's the other thing I wanted to add in, was a smooth transition. And, you know, using this render texture here as a big screen TV with a camera attached to the enemy, I can monitor that. But it also gives me ideas on how to surveillance enemies. I mean, if you build in a system where you're surveilling enemies, you can use a render texture for that and put it on like a little wrist. Or even your players, you can switch between your team. If you had a team of players, maybe have a little item that sits on his hand like a Apple Watch, and it has a little small screen there, which is basically a render texture. And you know, it's pretty cool once you learn the things that Unity can do, and you know how to do it in scripting. You learn some scripting, and you know, you learn how all these. That's really what this project was: learning about all the capability of Unity and what it can do. And then come up with, you know, the grand prize project. Yeah. See there now. I guess he's still running. He's in a sprint. I wish there was a way to zoom. Oh, I guess I could. I could set up another render texture, have the camera, or another camera that's with a render texture, and put a picture-in-picture of the pip that's inside is zoomed in more on him with a different camera view. And you can see our little house to the left there, the little old brick building house we used to use, way off to the left there. Yeah, so he's going through the upper waypoints. Now, the issue I had before, and I don't know if it's going to happen again, when he got to waypoint 16, which does say the next waypoint should be, see now over here, it's triggering it. It must be, I need to look at the angle. I think the waypoints are too big when you're on a flat ground. The waypoint's too large, is being triggered twice. At the speed that he's running through, it gets triggered twice, which calls swap twice. And I'll know that for sure when I do the debug.log. Now, the other issue, like I said, the other issue I was having here is when it gets to waypoint 16, it didn't seem like he went to waypoint 1, and I only ran it one iteration earlier. Looks like he went to 16 and then turned around backwards, like he was going back to 15. And again, I don't know if it's because of the slow speed and the sphere collider being so big, it could be triggered multiple times and causing confusion and reassigning him back to, see, it flips him back around as soon as he hits it. Now he's going back toward where he walked down. But waypoint 1 was off to the right there. Well, when you look at the front of the entrance of Trader Village as you walk up, it's off to the left there. Let's see what happens here now. Okay, he did go around a tree there. He was able to, the transform that, look at and rotate and all that allowed him to maneuver around a tree, which was good. I guess I want to see what happens here if he does flip back around and go back to 16, or if he basically is going to continue on going backwards now and coming back to position 1. I never let it go long enough to see what happens. But I'll be playing around with this. I don't want to just have the stream going where you're watching. Okay, so it does work. He's still running. Where it's just a bunch of this running around. You're watching this. You can see that later on, or rewatch the video as many times as you want when it finishes up processing on the YouTube side. But I'm going to end the stream at this. I'll make some tweaks to this. Put some debug.log statements in to make sure I understand how many times swap is being called when it hits each waypoint, and I'm sure I'll find where it's triggered multiple times. I'll also be working on I'll try real simple with a raycast to check the ground distance, and if I can get a simple solution worked out where he can stick to the ground better, that'd be great. Other than that, that's kind of what I'm working on, is trying to work out this waypoint system and fine-tune it, and then we'll be ready to add some NPC. Well, I guess before we really just throw in a bunch of NPCs, random NPCs, I need to work on being able to, deliver damage to the tiger. So he's going to need to be able to take damage when he's hit by a bullet. The way I'm going to implement that is every object, every game object that can take damage will have a function called take damage. It's going to be consistently named the same, and then this way, when the bullet, for example, is hitting an object that needs to take damage, if it's a different kind of enemy or a different object, they're not all going to be called possibly enemy. I might come up with different tags for these different enemy types, but essentially, if the tag's an enemy and I create these various ones, they'll have the same function. If it doesn't have the same script attached to it, we could potentially Well, I guess it would have to be the same script name on each one for each enemy. Otherwise, you know, you have a bunch of random script names. So I guess as long as that same enemy script is attached to it, it's not going to matter. So it won't matter. We can use the same tag and just call it take damage function. And so we'll have a take damage that will apply damage to the enemy. We got an enemy manager script that handles that. It mirrors sort of the player manager, where it tracks certain properties about the enemy, such as health and stuff like that. We'll have to create that. We don't have that currently. Yeah, so I'm curious about where he's going now that he... Well, here's actually the thing. It looks like because he went across the bridge, he basically took the same path, but he just didn't go back to point 1. He went to waypoint 2 from waypoint 16. Or at some point, because he started going, he didn't go the reverse direction around there and over the bridge the other way. I just realized he went across the bridge in the same direction that he went when we first started this. I guess since we got it this far, let's just wait and see what happens here. He's obviously not going to 1, because if he was going in the reverse direction, he'd be working his way back up to 1. And so we might have to have a direction variable that's flagged back and forth that starts at the starting realm, and it'll, you know, the direction would be forward, for example, meaning we're going 1 through 16, and then maybe we'll, at some point when we hit 16, we need to have a direction variable that swaps then that's not forward. It's like, you know, we'll have a Boolean maybe like going forward, and it's true initially when it starts out, and then it's false when it hits the last one, and then based on that check, we would have different logic code in the Waypoint script that will traverse from 16 to 15 to 14, going the opposite way. I mean, there's different ways, different directions. But here's the other thing. If we have someone that maybe we could specify, we'll just have a function called set direction, and then pass it in a value. You know, 0, like forward or back, or forward or backward through the waypoint chain, and this way we can inject an object to start at any point in the waypoint path, and based on the direction we tell him to go, he'll start traversing either up to 16 or down from that point to 1, and we'll also have a final destination built in. I also want to have, hopefully by the next stream, we'll have the you know, damage going on with the tiger, and working on getting that attack working, where in the roar, getting that worked out, where, you know, he can deliver damage. But that's going to involve modifying the AI here when he's moving, that if a player is within a certain radius of him moving around here, just in his AI manner, that he can then switch course. We'll have to set his destination basically to the player position, and so he starts tracking that player and every time the player moves, you know, he's getting updated player position, and he'll keep following. So yeah, I've got an idea how I want to implement the tracking once you hit a certain radius or zone, you know, or distance from that player. I'm not going to use any kind of raycast for that. The vector 3 has a distance static function that we used before when we were doing the drop You know, so what we could do is have the tiger or any enemy. This would be a functionality, a function that's it's a check. It checks the distance of that enemy to our player, or any object that's a player. And if it finds one that is within a certain radius, whatever that distance is that we decide is a fair red zone, let's say an attack zone, then he would immediately switch his destination to that player and continually get that position of the player and continually checking the distance from that player. So if the player gets out of the range of the zone, he'll stop pursuit. And so I think that can be easily accomplished. How well it's going to work, I don't know yet, but I know I have an idea already on how I'm going to implement it. Like I said, with the vector 3.distance, that would be a very simple way to do that. And also use an array cast. Actually, we might be able to use that instead of array cast. We might be able to use that as well to determine this tiger, how far he is from from the ground. And whatever that distance is, we could offset his Y position value by that ground distance to keep him at a certain. We'll keep him at a certain the ground distance. Maybe the first thing I'll try before I do the raycast. Again, I don't know if one is more expensive than the other as far as calling it every on the update function every frame, but I'll experiment with it. For one AI, it's probably not going to matter, but when you have hundreds or even thousands of NPCs in this world here, we got to look at that. We got to look at performance, overall. So I want to make the best, decision now, so we're not having to go back and re-optimize code at a later point. We can just, if we're trying to. Well, I am trying to knock out something quickly that can be playable, so I'll probably stick with something that works initially. But I want to be aware of if I can be aware of any optimizations that can be implemented without a whole lot of time involved. Just a few lines of code here and there, making a decision one way or the other, either a raycast or not. I can make the decision up front, but. I wouldn't think the vector. Matter of fact, I bet you the vector 3.distance internally it probably implements a raycast to do the exact same thing, so it may not be an issue at all. Yeah, he's going back to 16, so he's not traversing. So we need to control the direction and be able to have a function. We just have set the direction of the waypoint navigation, and so let's before we go any further, while I'm saying this, I'm going to just document this, so and you correct me if I'm wrong in the things that we need to make sure we implement. So we want to add function, set waypoint direction, and then also we want to add a final destination. So we can control what the final destination will be and actually stop them at that point. Bring it back to an idle state where it's just standing there instead of continually moving. Yeah, and actually the waypoint system makes it more organic looking. Like if you just had him. Okay, the other thing before I forget, smooth waypoint turning, meaning when the AI enemy here hits a waypoint, if it's in a different direction what he's facing, we want a smooth transition movement to that. We don't want it just this quick jerk, to that direction. Bam, he's going. I mean, it works for now, but when we're viewing it, it just makes it difficult to see it. That's why I had to move the camera up so high so I could actually see. But if I had a picture-in-picture with a smaller, which I may do that, pip with zoom. Again, this was just for debugging. This little render texture here was just for debugging to watch him without having to chase him around, and I could just kind of sit back and watch. I could eat lunch because it takes a while. I could eat lunch or go make something, a cup of coffee, and sit back. But actually, it's pretty cool in a way because I now see a real simple way. If you did this full screen, you could watch a player perspective, like a teammate, through the render texture. You do a lot with this. You can get very intuitive in this. You could have, like, literally, you could have movies built into a game, like a hidden menu where it's an undocumented feature where you can choose between a couple of Netflix movies and actually play back a movie and have it rendered to a render texture in game and like a hidden little object or whatever. You'd actually have a live TV, for example, in your game. Anything that comes from a stream. Take a little creative thought, but anyway, no, I'll just stick to the basics. I just thought that was pretty cool using a render texture. I actually saw this in a. I was looking at somebody's video where they were doing demonstrating how to do teleport. They have this could also be used, but what they had was, instead of they literally were doing what they called a seamless walkthrough. It appeared like you had a doorway that transitioned from literally one scene to another. They had two different distinct, when they zoomed out and showed their scene, actually two different areas. One was like on one side, one was on the other, completely separate. There was no terrain that walked through. Now these areas where buildings were walled in. It was like a building, really. It was walled in, and you just had a doorway, an exit on the room, and a same thing like an exit on the other room, and they were completely detached. There was nothing between them, just empty space. Like in your, if you look beyond the horizon there, you're starting to see the emptiness where our sand seafloor ends, and then you can see the drop off. But anyways, it was essentially two separate rooms like that with walls, like we're in right now. And when you'd walk through, for example, if you'd walk through right here, what you're seeing here, the scene that you would see, like I'm seeing here, we know this is a place to walk through, but he literally had it with a render texture that was in the middle of the door like this. And so in one room it would show a rendering of the inside of the other room, like the entryway to the other room, so it would transition easy. When you walked, you literally would transition or teleport the player instantly to the entryway of the other room, and you would never be able to tell that there were two separate independent locations. That because it was so smooth and flawless, and using the render textures on both sides, it would show a rendering of the opposite. It looked like he kind of walked up on it. I saw that. He triggered up and then flipped around. And I just realized what's causing that. So anyways, I'm going to work on that. I've got a few things to experiment with. I'm going to end this video right here, the stream. Thanks everyone for stopping out. Thanks for all the chat. Thanks for All the comments you've been posted, I appreciate it. All the feedback is great. I've been getting some feedback through private message, and uh, I appreciate all that. It's really helping. The encouragement to keep it going. Um, Obviously, I'm not getting paid for all this time I'm investing in this. This is just me spending time with Unity pretty much every day. Instead of playing video games, I'm working on being creative and learning and learning, taking my basic C# skills I had and applying it in the Unity environment. It helped to understand C#, just to make this transition that much easier. Yeah, so I'm excited about the progress, and there's more to come, and this will evolve, and it's going to, a little bit over time, we'll be evolving into something really great. So thanks again for stopping by. We'll see you on the next one. Look for the next stream where the things we've documented here, and on adding a waypoint destination, final destination, and setting the waypoint direction, and adding a little picture-in-picture for our debugging view of our AI enemy as it goes through the waypoints. We'll add that, and also that's so we can see how fast he's running, if he's going to run versus the walk easier. And also, we'll put some debugging statements to track if that swap speed is being called more times than we expect. And also, I'll probably, when we hit a destination, we'll go ahead and along with that, printing the swap information, we'll print all the information that's been set for the player, like his next waypoint, his destination, and his previous waypoint. And we'll see what's going on there, if that's being triggered multiple times, as to why he goes from 16 back to the other way. And he eventually, seems like he's going to waypoint 2. He's just bypassing one altogether, because he does go in the normal flow direction from 2, 3, 4, 5, all the way, and so forth. So that seems to be okay with that. Anyway, that's where we're at. Thanks again. We're going to end the stream now. Y'all have a good day. Check back tomorrow. Definitely we'll do an update stream tomorrow evening. I'll have to go to work in the morning. We had a holiday today, Memorial Day, so we've been off. This is kind of what I've been working on this morning. It's already like 2 in the afternoon, so 2:20 in the afternoon. I'll probably do a little bit more today, continue working on the changes. I do expect my children to arrive here sometime soon, so I may not have as much time to work on it as I anticipate or plan to. But if I have the time, I definitely will work on it and perfect this AI waypoint system and our AI movement in general, making sure he's staying near the ground. We're going to use the vector 3.distance function to see if that will help remedy this issue. So anyways, again, the way I approach something like that problem with him not sticking to the ground, is I'll use vector 3.distance to get the distance from the ground, and we'll debug log it first to see what values we're getting, and see if we're getting values that indicate the appropriate distance from the ground, and if so, if we know we're getting correct values, then we'll actually use those values in adjusting his position to keep him like glued or stuck to the ground. So yeah, if I can get all that working and all that worked out, and by locking the X and the Z rotation while moving on this AI Tiger, I'm almost feeling confident that we could completely write our own third-person controller, especially since I'm able to tie into animations now. And we may do our own third-person controller. It may not be such a daunting task as I first anticipated, especially since I'm looking at possibly buying one. I would rather have one that I can tweak, that I've written script for, which I believe in Vector, I think they give you all the script. I mean, you can go in there and correct that, and change it and modify it, like I was doing some of it. But I don't know. It's just the idea of having my own written that I fully understand and it's, as you make changes over time, you just, you remember everything that's been done to it. You kind of have this intimacy with it where you understand it a little better because you have that inner, the inner workings of it. So that's what I'm getting at. Anyway, that's going to end it for the stream. Thanks again for stopping out. Appreciate everything. Y'all have a good afternoon.